It's okay. Let's go. Hello, thank you for coming. My name is Gilles Noisette. I'm working for HPE for the Big Data Center of Excellence for EMEA. And I'm going to tell you about how we empower the data-driven organization, to talk about where we stand with some customer studies for you to see how our customers are using the different type of architectures where we have for big data and Hadoop, and also a bit about the future, how we see the future in terms of platforms and how it links with the future of Hadoop. So to start, what we call power the intelligent edge. So what is it about? We're talking about Hadoop. Very often we think about the data center. But every needs are not about Hadoop. Everything is not only in the data center. So it could be interesting to see a customer case, one customer who had a different need than only having the big data and Hadoop in the data center. Then I will present to you, I will go through the different, let's say, solutions we have around Hadoop. It's about infrastructure, it's about software, it's about services, and because it's not maybe enough, it's about add-on solutions also, what it is all about. I will take the example of the Elastic platform for analytics. This is really the type of architecture you will see more and more in the future. And just to finish, to have a look where we stand in terms of technologies, computer technologies, and where we are going. So let's start. If I tell you power the intelligent edge with Hadoop, what does it mean? What is it about? In fact, we have a good example. It is a deal we made with a car manufacturer from Germany, by the way. And it is about highly automated driving. So what does it mean? It just means that at one point in time, your car, if you want to do highly automated driving, the car has to understand, and it is what you have on the top, the object. So to the description of what exists, what is there, then to analyze the situation and make a kind of predictive what could happen, and decide and act. And it is the prescriptive part of it. So you know that one car doing highly automated driving need to do so. Level 1, if we see the different level for the monitored driving, the level 1 is just assisted for you as a driver. Level 2, it is partially automated. Where we stand now, we are at the start of the level 3, now in 2017. We are next is a conditional automation. After, we will have high automation in 2021. And after, maybe 25, we'll have a full automation. But for now, if we want to start to work on that, if we want to develop this type of technology, what do we need, in fact? So first, we have to understand that before, where we were getting data, because it's about data from a car, we had a bit of data. You know, you had, in all cars now, you have standard buses. And from these standard buses, you are getting some in terms of data, machine data, something like 15 megabytes per second. Okay? At the end of the day, if you have an 8-hour day, and you did testing, and you're getting all the data, what do you get? Something like 500 gig a day for one car. So just imagine a car manufacturer is going to do testing for more than one car at a time. So, but anyway, for one car, one day, 500 gig. Now, if you have all the new sensors we are putting to the car to do the highly automated driving, so you have more type of data, you have more data, and also because you have more complex data, and you have videos, you know, as the complex data, it is clear, and all this data mean you have a lot of data. And that's where we start to talk about big data. Because at the end of the day, so first, in terms of throughput, something like 2 gigabytes per second. And at the end of the day, you have 50 terabytes for one car. Okay, 50 terabytes for one car. So it starts to be something you can't manage with a workstation, for example. So how to address this kind of need? The traditional IT tools, the methods you are using, or people who were using before, are not anymore applicable to this kind of case. So the challenge now is to be able to do this, to be able to handle all the data. And first, all the data are relevant. You want to keep all data, to trace all data, to keep all data. And because they are coming too fast, you can't move the data to the data center in real time. Because people are testing cars everywhere. I mean, sometimes it is in factory, but sometimes it is in the mountain, sometimes it is in the desert. They are analyzing, the behavior of the cars. So it could be anywhere. Then you can't transfer the data in real time. So how to make it, and what does it mean in terms of size, overall size? If we take an example, just an assumption, you have 10 vehicles more each year to manage. You have 50 terabytes per day, 120 average day per year, 2 different locations. In fact, at the end, you are talking about petabytes, and maybe after zettabytes. So we have a real big data need here. So what do we need? We created with this car manufacturer, we created a concept. We call it master data management in a box. And the idea is to be next to the car, where the testing is done. So we are calling it computing at the intelligent edge. And as you can see here, we have one system. So we have ruggedized systems with server in it. And the card you see, the ProLiant server cartridge you see here, and I will give you more detail on it later on, because we'll use it in different contexts. This is a real server. This is a strong server, by the way. So a real server, but in this size. So first we have a box with this server in the car to get the data, to really capture everything. Doing a bit of analytics already in the car. But then, next, we are transferring to the MDM, to the local box, where we have, in fact, all the stack we need to be able to handle the data, to process the data, to analyze the data, and to understand about it. And this is something local. This is something you are moving. You see the box. You are moving it. If you are going in a different place to do testing, you are moving the box. Between the two boxes, you have LTE communications in terms of networking. So looking at what we call the local box, you have on the left. We have remote management. We have this ruggedized rack for transport. We have, I think it is done with NORCOM in terms of analytics, so distributed analytics that is done. You have a Hadoop layer. Sometimes it could be Hortonworks or Mappa. It's a decision of the customer. And at the bottom, you have standard optimized servers for Hadoop. So this kind of box, this MDM box, allows to analyze the data really at the edge. And when we compared what we can do with this cluster next to the car, compared to what was done with workstations before, it's just that we are coming in terms of for one job to run from 3 days to 1 hour. So we are solving the problem of moving the data, because it's not possible, by having the cluster next to the car. And you will see this sometime. We say powering the intelligent edge. So just to show that you can't, and when you are in the IoT world, you can't move all the data. You have to process the data in place somewhere, and after, to move what makes sense. In this case, it is funny because I'm not moving the data from the box to the data center. I'm moving the box to the data center because I'm not going to use a network to transfer so much data. So what they are doing, when they are coming back, at the factory, they are connecting the box with a 10 gig network, and then they are transferring the data in the data center. But they have been able to do what was needed at the edge, on site, to manage the data. So just an example, computing at the edge. Now, if we are talking about solutions about Hadoop, and I'm going to rapidly on all our solutions. We want to put and to set Hadoop as enterprise grade. So you see this kind of slide very often. You are adding Hadoop because it's adding value. You are getting more insight from the data. You are complementing maybe the enterprise data warehouse. But Hadoop in itself is not enough. You need Hadoop for sure. It's about Spark. It's about add-on. It's about new software stacks that are coming. And it's about a good infrastructure for it. And then you can get the analytics, and then you can get the value. So the idea is to do something that is flexible, that is enterprise grade. We have the right services to help people to set that up, and add-on solutions. And today, to make it simple, we are mainly and it's just to simplify, because you can do a lot of different architectures for Hadoop with our systems. But we say that we have a standard edition, let's say an elastic edition. So standard edition, you take a standard system, a standard server, the DL380, for example, that is the most sold in the world, and you use it for Hadoop. Fantastic system. You have a very good performance and a core spindle ratio with this type of server. So you get a very good performance for Hadoop. So very good, simple way to implement Hadoop. The traditional one, you are building your cluster. And then you have the capability, and we have the capability to resell some licenses. So mainly today, we are selling licenses for Cloudera and subscriptions for Hortonworks. I think we will have something about Mappa, but you can take Hadoop open source. It works also very well. Just what we can sell. And you have services around that. Now, there is another architecture, and we are pushing this architecture now for 2-3 years, and you see that now it is happening. More and more you will see this type of architecture. It's an asymmetric architecture, because Hadoop is getting asymmetric more and more. And it is becoming, I would say, natural for Hadoop to have computing and storage split, separated. So this architecture, we are building it with, I would say, more optimized servers. The DL380 is good for many workloads. Then we have servers that have been optimized for high-performance computing, for example, and that the servers you have at the top for the computing, or servers that are very dense. And on a storage point of view, we have servers with a lot of drives, with a very good throughput, very good in terms of IOs. So this is the type of architecture we have. I'm going to describe a bit about the architecture and to tell you about a case study, a customer case study about it. And same idea, Cloudera, Hortonworks, Mappa, Apache, Hadoop. When you start to have large clusters, because the idea of this type of clusters is when you have many workloads in parallel. And that's what you are getting. 3 years, 4 years ago, people were doing MapReduce, not that much that MapReduce, so you had one kind of workload in general. Now you have many workloads, many needs. You are doing kind of analytics, you are doing maybe MapReduce because it's still very good and scalable. You can do deep learning, for example. You can do many different type of workloads, run different type of workloads on the same cluster. And with this type of architecture, you can have different nodes for different computing needs. So it's interesting to have a cluster management utility that has been developed for high-performance computing, and it is rack-aware, like Hadoop. So it has been really easy to adapt that to Hadoop, to manage Hadoop. We are showing that on the booth, on our booth. And the services around that. And the right, I would say, the right services at the right time in the process. So to talk about these services, we can split that in three parts. The first is to understand what to do with what data and build a roadmap. We know that it is key. It is easy to set up Hadoop and to start to work, but you know that it is not easy after to live with this type of approach. So first, understanding, and these are the advisory services, understanding what data, what use cases, do a roadmap to start. Then the second one, it's about the architecture of the cluster, how to design the cluster. You want to start, and now, what about what type of cluster, what type of nodes, how to orchestrate, what choice of platform for the future. Then the implementation services to deploy Hadoop the best way, to make it easy to use after. I was telling you about the Elastic platform for analytics. So what is it about? The idea is if you have a standard Hadoop, you don't have really elasticity. I mean, if you can add nodes on the fly, even in your cluster, but you are adding at the same time storage and computing. If you want to remove nodes, on an HDFS point of view, it is complex. It is hard to remove nodes. It is not designed that way, HDFS. So you have tricks to do that, but it's not done this way. So in general, people are adding more and more storage space, more and more nodes on the HDFS side. But what about the computing? Because in fact, if you split the storage from the computing, if you have just a data node service, because we're talking about the standard Hadoop, just with the data node deployed on the storage nodes and the node manager on the compute nodes, then you have compute and storage with a very standard Hadoop distribution installed. You have compute and storage. And on the compute point of view, you can add nodes and even remove nodes easily from your cluster. And you can have, and that is the beauty of this solution, you can have different type of nodes. You can have nodes for different usage. When I was telling you about standard nodes for ETL, for example, MapReduce, and then big memory nodes, maybe to do the analytics with Spark, and then GPU nodes, and even we are going to have nodes with FPGA. So FPGA is the way to put the software on silicon for people who really need performance, when milliseconds matter. And for some use cases of our customers, mainly I saw that in finance up to now, milliseconds matter in the cluster. So this kind of node could be really interesting in terms of computing. And why we see also this split between the computing and the storage? Because now, and for more than 1 year, you have the HDFS tiering feature available. What does it mean? You might have nodes with very fast drives, flash drives, SSDs, nodes with standard drives, and nodes that are designed for archival. You have the best price per storage, let's say, price performance for storage, with nodes with a lot of drives. So it makes it really scalable, flexible, and in terms of cost, optimized, because you can add compute when you need, storage when you need, and you can add the right storage at the right time for the right workload. So let's take the example of one of our customers. And this customer needed to analyze, so the clouds, not the cloud, the real clouds in the sky. And the idea was they needed to optimize, they needed to reduce the cost, to increase operational efficiencies and automation for their cluster, for the future of the big data. Agility, efficiency. And before, they had people analyzing the photographs, to recognize a different type of clouds because it makes sense for their business. Human people are slow at doing that, even if they are very good at doing that. So they wanted to really find a way to automate this with the right platform to make sure they were doing it fast and at scale. So it was about scalability. It was about a variety of workloads, different type of workloads. They knew they had different type of workloads, and they knew they were going to have a lot of data. So they wanted to build a data lake. And to start, they had something like 1 tier of a petabyte to start. And they are planning in the coming years, in 3 years, 5 years, something about 20, 25 petabyte of storage. But they want to make sure the storage is online, The storage is in HDFS. So it was about using HDFS tiering. With hot and warm data, you can access rapidly because they are on standard storage servers. And old data, cold data, that are more archive type of servers. So that's why they decided to go for the Elastic platform. So I'm not going through the detail, all the detail of this slide, just to show the type of blocks they decided to take. So if we are looking first to the storage part, you have the Apollo 4200. These are the standard servers for storage. So you can have up to 28 big drives in it. And now we have the 10 terabyte drives. So it means raw 280 terabyte per server. It is a maximum, people are mainly using 4 terabyte, 6 terabyte drives right now. And the Apollo 4510, the dense storage. And on the Apollo 4200, you have a good balance between compute and storage. So then when you are getting the data, it is very, very fast. For the archive node, you have less compute, and you have up to 68 drives, up to 680 terabyte of raw storage. With this one, less computing because the goal is not to get the data very, very fast, but to store the data the most efficient way. And this is transparent after. It's HDFS tiering. So when you are reading on HDFS, the name node knows where are the blocks. You don't need to know, your application don't need to know. That's the beauty of HDFS tiering. On the computing side, they decided to take 2 types of nodes. The first one, we call it a dense, low latency optimized block. It is about, the card was used in the first example, about this cartridge, this moonshot cartridge we are using. And I'm going to describe the cartridge just after. And we have enclosures where you have 45 servers. In something like 4U, you have 45 servers. And they decided to start by buying 4 of them, which means 180 servers is 16U, which is not bad. So I'm going to describe the cartridge after for you to see. But if you want to recognize the cloud on one photo, what type of cloud and all the details, then you need to be able to do deep learning. We know that this is something that is a lot done with deep learning right now, recognizing photos, images, what is on the photo. So this very special use case was really matching our deep learning block. So where you have servers designed for computing for HPC with NVIDIA K80. Now we are switching to the P40 in the coming configuration, but the K80 is still a very, very good card for deep learning. And they decided to put the head nodes, the name node and resource manager on VMs. It's the way they are using it. So this card I was talking about, the one we are using at the edge, and when you need to save power, and when you need to save space. So I don't know if electric power is a constraint for you in your data center or for your customers today. But we see more and more this becoming a real issue for people. And one server like this one, a maximum in terms of power, electric power, is 90 watt. 90 watt for one server. And I'm talking about a server with 8 or 16 cores, which start to be good, 128 gig of RAM. It's something you need, you know, if you want to do Spark, if you want to do analytics, you need at least 128 gig. 2 drives for data, so 1 for the operating system, and 2 for data, and they are M.2, you know, these small cartridges, but NVMe, which means it's SSD on the PCI bus. So why we are talking about low latency? That's why these nodes are interesting in terms of low latency, because you have a very, very fast storage on the board, on the card. Which means that when you are running Hadoop, and for example, if you have an edge-based case, everything about temporary data will be local on this card, but all the data after will be in HDFS. So optimizing, you know, the transfer. And in terms of enclosures, you have the Moonshot, 45 cartridges, or you have one node that is named Edgeline 4000, where you can have 4 of them. So in addition of the box where you can have one node. So this is more for the data center, but the Edgeline 4000 can be at the edge also. We have special brackets to put it everywhere. It is ruggedized, so you can have in different atmosphere with different temperatures. So the idea is this, for them, they want to use it for MapReduce, for analytics, to a certain level. Then for deep learning, they want to use this configuration. Just the idea that in the back of the 2000, you see on the top left, in the back, you can put 2 of these servers. And in these servers, you have 2 K80 NVIDIA cards, which means into you just have 4 NVIDIA GPUs, very, very efficient to do deep learning. So this, you know, specialized block for specialized workloads. So the first one, they are using it for nearly everything, but when they need to do something else, they need to GPUs, then they are using a deep learning block. When I'm talking about add-on solutions, what are we talking about? We are talking about today, mainly to start, I would say, when you start to have Hadoop, when you have a lot of data, it's about object stores. And object stores, we have a lot of different reference architectures for object stores, but we are concentrating today on Scality and Ceph. Ceph for the open source. We are working a lot with Suzy on that. And Scality is really one of the best solutions today in terms of scalability for object storage, with S3 compatibility also, which is quite interesting. Also, we have an important play with SAP. SAP HANA. We are selling a lot of SAP HANA. We have converged systems, so kind of appliances for SAP HANA, ready set of servers for SAP HANA. We have a very good success with that. And I don't know if you know that, but since last year, there is now something named HANA Vora that really makes it easy to integrate Hadoop and SAP HANA. Vora, in fact, is a kind of superset of Spark. It is Spark plus some SQL capabilities. So it means that if you have SAP HANA and you are using SAP HANA for the hot data, you can use Hadoop for the warm and cold data or for some other processing. And you can really connect the both worlds. I mean, you can do queries from HANA. Naturally, it is transparent from a part of the data is on HANA and the other part is on Hadoop. And it makes it transparent to you as a user. So very good solution. It's also about data encryption. So we are showing the integration. We are showing a demo about SAP HANA on Hadoop on our booth. We are also showing something about secure data. Secure data is a way to encrypt the data at the edge when you are ingesting it, and to keep it encrypted from the time where it's leaving your data center for any reasons. So really, in Hadoop, it is integrated with Hadoop, and now with NiFi, then you can encrypt the data and protect the data all along the data lifecycle. We see also the need and a trend about multi-tenancy. And I'm going to describe this one a bit more. And multi-tenancy, the way to do Hadoop as a service, I would say. And we have a partner that is named Blue Data. And I will show the type of architecture we see more and more. And it's really, a lot of people are interested by this type of solutions. And to finish, we have SQL on Hadoop. So it is a columnar database that is running on top of Hadoop. So using Hadoop as a data store. And you have all the logic of Vertica that is very efficient, full SQL on Hadoop. So Hanavora, I already told you about it. Hanavora, what is interesting that you can do automatic tiering of data. So this is really interesting. You can get data that have been processed in Hadoop and move the data easily from both worlds. You can also give the access, if you have your people managing the data, accessing SAP HANA, through HANA, they have access to the data in Hadoop a very transparent way. So secure data, for you to understand a bit more how it works. If you have ETL job, Hadoop jobs, just by the time you are ingesting, we have plugin for different mechanisms. You have for scoop, you can encrypt the data. And it is really the idea to have an end-to-end data protection, end-to-end data encryption. And also the beauty of it that you can just encrypt what you need. So you can preserve the format, and even you can preserve part of the data. If you want to do analytics on the data, even if you don't have access to everything in terms of in one record, you can keep part of the record readable when the other part is encrypted. So you can partially encrypt your data. That's what we call the format preserving encryption. This is very interesting. And as I was telling you, you have now the integration with NiFi. And we are talking about GDPR. We are talking about really being ready for next year. Compliance. So it's for EMEA or Europe about GDPR. So in a bit more than 1 year, people should be ready in terms of security. And this is typically the kind of component to help people to make it. I was talking about multi-tenancy. This is a very good example. What about having Hadoop as a service? A Hadoop you can provision easily on the fly with a framework managing it for you. So first, to do these kind of things, it is really interesting to have computing and storage separated. So by the way, it's good because it fits really with the Elastic platform I was telling you about. Then, once you have computing and storage, you can, on the storage side, protect, do data isolation in terms of security. And on the computing side, decide using Docker. It is typically the technology they are using. Using Docker, you can decide to deploy one cluster or another cluster, different version of Hortonworks, different version of Cloudera, different versions of Spark, or even tools. So you can, on the need, you can deploy different type of big data. It is big data as a service, in fact. So this kind of architecture, we see it more and more. Our customers are really interested by that, and we are working to make it more simple. And with the Elastic platform, really, it works very well. Now, what about the future? What about the future of technologies, platforms? Because we know quite well about the platform. But what I want to do is link also with the future of Hadoop. So first, we have new technologies in our servers. This is not really new. We have that for months. We have persistent memory. We have NVDIMMs. So these NVDIMMs are really interesting because if we are using as it is, not changing anything about software for databases, because we did first testing on databases, you are going twice faster than the benchmarks we did for SQL Server. If you rewrite a bit of SQL Server to be able to use this memory, to use this NVDIMM, not as a block storage like a drive, but like a standard memory that is not going to disappear, let's say, then you are getting 4 times the performance. So this works for databases now. This is something that is available today. And we are talking about 128 gig of RAM in one DL380, for example, in one standard server today. This year, around fall, we will get to 1.5 terabyte. And next year, we will get to 6 terabyte. And this is for any type of technology. What about Hadoop then? What about speeding up Hadoop? Because if I have a new technology in my server, why shouldn't use it for Hadoop? And that's what we are going to do, in fact. But we are working now. I don't tell you what is done or not done yet, but people are thinking about what to optimize in Hadoop. May I use it to use HDFS cache? No, people are not using too much HDFS cache. But would it be possible? Something that is quite sure, we can speed up the name node service. Using on the logs, the name node logs, that we can speed up. And there are many places or features where we should be able to optimize Hadoop. So this is with a standard technology that you have, now you start to have on all the servers. Now you have it with NVDIMMs, fast memory, and in the future, next year, you will have the Intel 3DX point, you have HP memory store. So we are talking about huge size of memory coming. And then we are talking about terabytes in the first time. In a few years, we are talking about petabytes. So this is interesting because we are going to get, in fact, systems where we'll have petabytes on non-volatile memory. The drive will be used for archive. But you are going to do everything in one pool of memory. It is one way to see it. We see. But if you can do it very fast with one big pool of memory, that's the way it will work. So we are going from a processor-centric type of architecture to more a memory-driven computing. So this is interesting if you want to run a big load on one big server. But at one point in time, it will be interesting to have multiple nodes or containers in this server, to have a cluster, but with still a shared memory. Because then you can do the shuffle in this shared memory. So you can share the data between all the nodes. That's what we are doing typically with Spark. And when we did the testing with Spark, the test with Spark, we found doing the shuffle in memory because we started to try it, to test it on large memory systems. We got it to run 15 times faster, just because the shuffle was done in memory between nodes and not anymore on the drives. So something that is interesting also for the future. And if you are doing similarity search on photos, a lot of photos or pictures, then you are going 20 times faster. Something that is interesting for a large pool of memory, for memory-driven computing, is when you are doing graph analytics. Because then you have the graph in one pool of memory. And you get something like 100 times faster response time. For financial models, we found something really impressive. So we see it as one of the future. And this is coming in the coming years. We are talking about Hadoop version 3.0. maybe it will be there, so it will arrive end of this year, and after we will have for 4 years, I don't know, in terms of version. But this type of technology will come. And we are talking about technologies, consortium working on this type of memory-driven computing like Gen Z. So when I was telling you, we see that we have the split between the storage and the computing and different type of computing, it means also that it is open for the future. When we will have next technologies coming, we will be ready. And we think that the future of Hadoop, and that's what we see, the Data Lake 3.0, will be, in fact, Hadoop in the cloud, public cloud, private cloud, so more on object store, or when it is on premises, you will have different type of storage and different type of computing, scale-up computing if you have this memory-driven computing, or scale-out computing with standard servers, more and more Dockerized, more and more with containers, and we will see the integration between the object store in HDFS. That's something that is already on its way. So we'll see something that becomes natural in terms of storage and in terms of computing. Different type of computing for different type of workloads and different type of storage for different needs in performance. So it was what we were thinking about it, and we see also that we will see more and more an easier way to transfer data between these different tiers, these different type of clustering, to make it as one system for data. So I see I'm already late, but I'm very happy if I can answer questions. Would you have questions? No? No, thank you very much. I see a question there. So there is two approaches today. The first approach is to have erasure coding in HDFS. It is coming in version 3 of Hadoop. This is good, and in its first version it works, you know. It will be used by Facebook, Yahoo, or the new Yahoo now because they changed the name. But it will be used by them as soon as it will be available. So erasure coding in HDFS is good. But what we see also, and there is a session I think tomorrow done by Microsoft and Western Digital about HDFS 9809, and it is the way to mount object stores in HDFS namespace. So this will be interesting also because for people having an object store outside of Hadoop, they will be able to use it, you know, for the mail, the cloud, whatever, and also to mount it. And I think at start it will be compatible with Microsoft and S3, and they will be able to mount it as a namespace in the HDFS namespace. So it is two different usage depending on what people are doing, depending if they have an object store aside of Hadoop also. Okay, thank you very much.